Gonna go ahead and get started as folks get settled in. Feel free to introduce yourself in the chat and let us know where you're tuning in from today. We'd like to know who's on our meeting today. Thank you. Next slide, Jennifer. Well, welcome everyone. Good afternoon. My name is Itzel Torres with 3C Ren, working out of Ventura County. Today we have targeting zero net carbon design, energy performance for zero net carbon operations with Andy Keys and Jennifer Rennick from Imbalance Green Consulting. We're really happy to have them there. But before we get started, just a little bit about 3C Ren and who we are. For anyone that's new, a little bit about 3C Ren. We are the Tri-County Regional Energy Network, a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering programs and services for building professionals and households. 3C Ren is funded by ratepayer dollars, which are collected to the public's good charge, funding our utility bills. We currently have 3 programs. Next slide, please. The first one being our Energy Code Connect, where we offer industry trainings, regional forums, and Title 24 consultation services called the Energy Code Coach to help building professionals navigate the California Energy Code and green building requirements. The phone number will be listed in one of our slides towards the end. More information to come on that one. Our next program is a building performance training program, which we offer trainings on technical and soft skills related to building science principles and systems for high performance building. Our goal is to bring industry recognized certifications and training providers to the Central Coast that will help advance people wherever they may be at in their career. And our last program is our home energy savings programs, which serves households that are historically underserved with free and discounted home energy upgrades. For any multifamily property owners or contractors that are interested in participating, please feel free to reach out to us and fill in our inquiry form about that. And I'll provide more information to you at the end of our training with links where you could find these things. And without further ado, I'll hand it over to Jennifer and Andy to get us started today. Thank you.
Great. Thanks so much, Itzel. It's really our pleasure to be able to partner with 3C Ren to be able to provide education and training as well as get education and training. So really grateful for that program. As many of you know, or probably inspiring you to be here in the first place, is that the state of California has a relatively new requirement as of 2023 that architects must have 5 hours of continuing education in zero net carbon design in order to get licensed. So in addition to the access compliance 5 units of continuing education. So this course was set up, this series, to be able to provide those 5 units, as well as earn AIA Health, Safety, Welfare learning units. So if you're doing the whole series, they build on each other, but they're also, each one is a standalone unit. So, and then just in terms of logistics, we're going to be getting the AIA, or the AIA learning units will get reported by 3C Ren as you register. But for that certificate at the end, Itzel's going to wait till the end, and then she'll send out to everyone the 5 hours, and it's, you know, it's self-reporting, so it's kind of her own invention of what that looks like in terms of providing the required information for licensure. If you have questions, we can answer those as we go. So series outline is 5 parts. Last time was the targeting zero net carbon design, kind of the overview, how we got here, what's the background. Today we're focusing on energy performance for zero net carbon operations. So operational carbon is the focus. Next month will be the energy water nexus, followed by embodied carbon, and then wrapping up with regenerative design. Covering the gamut here's our learning objectives in terms of getting those AIA units, just as we've talked about. Okay, we'll go ahead and jump in. So energy performance, here we go. So in this presentation, we're going to walk through why all electric and lower carbon all work together, right? So this is a focus on carbon. In general, we talk about energy efficiency, and in this one, energy efficiency is certainly a part of it, but the low carbon also means the all electric, and in terms of what California is bringing to this. We're going to talk about heat pumps and just some of the logistics, and happy to answer questions along the way. That big hurdle about cooking without gas, we'll spend a little time there. And then just those better building envelope, et cetera, and wrapping up with renewable energy and resilience, including energy storage. So a lot of how-to. We'll touch on code just a little bit as it comes up, but otherwise we have a separate series on the building code and how all that applies. Okay, so also as a reminder, you'll get a PDF of all the slides at the end, so you're welcome to relax and not have to take too many notes. And then the other is that we're monitoring the chat, and if you have questions, type them in there and we'll go ahead and either interrupt or save them to the end, depending on the, kind of where that is. But we will have time at the end as well. All right. So lower carbon footprint with all electric. And this is just kind of that hint, this image of a ginormous field of that utility scale solar electric panels. And we're getting everything from solar, tiny little cell for having a light in your garden to this kind of scale, and but that's clean, carbon-free electricity. So California is at the tipping point where more of our electricity is coming from carbon-free sources. So that's the great news. And as you go through, carbon-free is not necessarily renewable, right? So hydroelectric, large-scale hydroelectric is still considered carbon-free, which it is, but it is not considered a renewable energy. So we're on a path towards renewable energy, such as wind, such as solar. But overall, we're definitely on the trend towards a clean energy grid. And that makes all the difference in the world, right? 10 years ago, if we're making most of our electricity with gas, then it doesn't make any sense to convert gas to electricity and then electricity to heat our homes, right? Then it would be more efficient to use gas to directly heat our home. But as we move away from fossil fuels to generate electricity in the first place, that's how it becomes carbon-free. So that's the push for all electric. And Jennifer, feel free to jump in if I miss anything you want to expand on. So
I'll jump in just to apologize that I have the static electricity on my mouse pad on the computer.
Oh no.
So I switched how I'm advancing the slide, so I just want to apologize to you all.
Okay, good to know. Great. Okay, so the why the push for all electric? Well, at the most basic level, that's where it's required by the code. So wherever you are philosophically in terms of energy and climate change and carbon, et cetera, the reality is that that's our energy code is going in that direction. So all electric used to be a little bit of an uphill battle a couple of code cycles ago, but increasingly not only being more responsive to those who want to go all electric, it's leaning the credits more towards that way in order to meet those goals. Next is that the PV panels are required for low-rise residential and non-residential construction. So last code cycle, it was just introduced for low-rise single-family homes, and then this code cycle, and it was PV ready in non-res. Now this code cycle, it's required everywhere, depending on the size of the project. And then battery systems, right? So we're having we talked last time about the duck curve and the issues of having a lot of renewable energy from PVs in the middle of the day, but then as it goes into evening, not having as much renewable energy. And so, and a big electric demand because we're all charging our devices and cars and such. So batteries are playing a bigger role, and they're now being either required or at least be ready for batteries as they come in. So, and folks want them for resiliency, right? As if we have a power safety shut off by the power company, to be able to have your refrigerator lights and you know, some outlets for charging things. I mean, it makes it really kind of seamless. So that's a big help. And then this all electric technology has just gotten a lot better over the years, right? So heat pumps and all kinds of applications have really gotten very good. Reasonably affordable. Nothing's really affordable in this inflationary climate, but it's certainly comparable, so that heat pumps are becoming the standard. And they're high performance, so it's working really well. So that's why all electric is gaining momentum. And then in terms of the built environment, and this is a distribution graph of energy breakdown for the Western Pacific region, which includes California and other states in the Western Pacific. And this is kind of that old language, and we kind of put that up there just to remind folks to look at this kind of language with a bit of a critical eye, or a discerning eye, when it talks about transportation and then residential and commercial. And then construction industry, it's a super small percent. But what we know is that what this really is a lot about is the building. So the residential consumption and the commercial consumption is almost entirely about the building itself, in terms of heating, cooling, lighting, moving water around, all that type of thing. So instead of calling it residential and commercial, famous architect Ed Mazaria said, look, that's about buildings, not just this sector. And then even in the transportation, there's a lot of the construction industry that is using transportation to get those materials. We'll talk about embodied carbon in depth in session 4, but we touched on it a little bit last time as well. And then within the building, the left chart on the left there is showing national residential end-use energy consumption, just as an example. And then the one on the right is specific to that Western Pacific region, which tracks California pretty well. And so just kind of walking through the California one, space heating, 28%, water heating, almost the same, right? So air conditioning in a home is pretty small. That's probably going to shift a little in terms of climate change and more folks adding air conditioning. And then, you know, refrigeration and lighting, and then the other of just all the other appliances and devices that we charge up. So water heating and other takes up a bigger pie chart, a bigger section of the pie than the national, mostly because it's a smaller pie, right? It's a milder climate. We don't have as big a space heating load as the rest of the country has. So kind of order of priority as we think about where to save energy and what our opportunities are for looking at energy overall. And with that, we're going to jump into the key to all electric with heat pumps, and I'll let Jennifer take over from here.
Okay, thanks, Andy. Let's see. Well, last time, as kind of the introductory, we talked a little bit, Andy mentioned it, something called a duck curve. And if you didn't catch the first series, where what we were referring to with that is that even if your space heating, so I can go back one slide here for just a second. So even if the space heating is natural gas, and this is energy end use, so all the energy together, even if the space heating is natural gas and you switch that to electric, with our current grid system, that electricity may potentially come from a power plant that is burning natural gas to create the electricity. So some of what we're talking about with the overall pathway for zero net carbon, it also includes how do you make that electricity, and then what technologies can we use to use electricity as opposed to natural gas, but also to use electricity when we have PV and solar. PV solar and wind power or hydroelectric. And so a little bit later, we're also going to hit on the batteries, because why that batteries are important is if you get the electricity from the sun or from wind during the day and store it in your battery, then in the evening, you can use electricity in the form of heat pumps to heat your hot water and deal with your space conditioning. And thereby it's that combination that is reducing the carbon footprint of the operational energy. So with that said, I'm going to talk a little bit about the key to going all electric, which really is all about the heat pump technology. And so in this picture, this includes outdoor condensing units for heat pumps, and one of them is for the hot water for this building complex, and the other one is for space conditioning. A lot of folks don't understand quite how heat pumps work, and they're not really sure how to broach that topic with their clients. When folks think of heat pumps, they're not really thinking of refrigerators or air conditioners, but basically your refrigerator and your air conditioner is a heat pump. And the heat pumps that make heat for heating our homes or heating our hot water, it's kind of the same heat as you would feel like at the bottom of your refrigerator. If the compressor's at the bottom, it blows the warm air at out the bottom of the refrigerator. So if you can imagine that amplified and expanded up, then instead of blowing that warm air out of the refrigerator to keep the inside of your refrigerator cool, that warm air has really been sized to heat your whole house. And this heat pump technology works in even minus 20 below 0 Fahrenheit temperatures, still heat in the air. And this is a diagram of what that kind of looks like from Mitsubishi, where you've got the outdoor condensing and fan coil unit that pulls in cool air from outside. In this case, it pulls even the heat from that cool air and blows out even colder air. And that heat is transferred into your indoor fan coils or indoor wall units that provide heat for the space. And it turns out with the new technology that this is just, it can be done very, very efficiently. Same concept goes for heating hot water. And this is an example from Ream has a great video on how the integrated heat pump water heaters work. So this heat pump is sitting on the top of a large water tank. And so it pulls air in with a fan from, in this case, like a garage, and it transfers that heat through those coil into the tank of water. And then what exits on the side is colder air, because the heat that was in that air got transferred to your water. So they're super easy to install. There's no flue since there's no combustion, no gas piping, again, because there's no combustion. And so this type of water heating system has a lot less greenhouse gas emissions, carbon CO2 equivalent compared to standard gas or standard electric water heaters. And these kind of units really, depending on the brand, they're 2 to 4 times more efficient than a standard electric heater. And they're comparable to operate to a on-demand gas unit. So they're very close in the amount of money your client will spend to operate the appliance. And then you combine this with like some smart controls and you can reduce the carbon footprint overall by quite a bit. The other places we see heat pumps that folks aren't really familiar with is, for now, heating pools. We also have heat pumps or condensing units that are used for our dryers. Also, we have heat pumps that are being used to heat and cool the cabins of all the electric vehicles. And then we have a variety of heat pumps that are used for conditioning our spaces. And they can be used commercial scale, large scale, multifamily scale, and residential. And so we have different types of ducted systems. We have types of ductless systems, including wall mount, floor mount, different types of ceiling registers. And then even those packaged units that you see kind of in the windows, lower windows of your hotel motel rooms, those are also heat pumps. And by the way, the newer models have become a lot more energy efficient. Don't really think old style motel, but the newer ones, very energy efficient. Heat pumps also are used, like we mentioned, for heating hot water, but they come in a variety of types, both to address single family, commercial scale, large commercial, and large multifamily projects. And this is just kind of a variety. They're both what's called an integrated system, where the heat pump and the tank are together. So that single family one, that A.O. Smith one on the far left, the condensing heat pump unit is on the top of the tank of water. And for A.O. Smith has a commercial version where they've got the two fan coils, and the condensing, the heat pump part is kind of in front, and then the large tank is just behind that mechanism. And then we have types that are split, like the Sanco 2 unit. And these can be ganged up, by the way, so that you've got an outdoor heat pump unit, and then it just transfers the hot water to a tank that's positioned inside either the home or a larger tank that is positioned someplace else that might be used for multifamily situation. When it comes to the heating and cooling for our spaces, there's a couple different types you might want to familiarize yourself with if you're not familiar with this type of system. But here's an example of wall mount, and it kind of gives you a sense of the scale. And this is very common in Europe and Asia and Australia, and it's becoming more common in our country. At first, folks weren't, I think in our country and even California, weren't too enamored with the wall mount, although I see it a lot more. People are getting used to the way it looks. But if you don't want, or you have a client who doesn't want the wall mount, there are recessed ceiling options available, such as that unit in the right lower corner. And it's wide, I mean, and pretty long, but the width is designed to fit within a narrow space, especially between the framing members of your ceiling rafters. But if your client also doesn't want the expense of that, or if you're doing a remodel, sometimes it is easier to do the wall mount. So you could see the image on the lower center. Up on the left-hand side, you'll see a wall mount unit up high, and that's enough to heat that entire space. And it just has a gentle fan, and there's louvers at the bottom that you can also custom direct with a remote control if you want to keep the air off of you, or if you're in cooling mode and you actually want to feel that breeze on you, you can angle those louvers down, and so it would hit the folks on the sofa. And then there's an example on the upper photo where they've kind of disguise the wall mount unit by putting it behind louvers. I caution you, if you do that, you do have to design it so that it doesn't impede the airflow. And so what you don't see is that the air it comes out the bottom and easily could come into the room. And you may notice in that there's no decorations or no true shelf at that bottom portion. And that's where all the air is allowed to flow freely. There's also air handlers. So you could have a completely ducted system. So you have your outdoor heat pump outdoors through refrigerant. That's all either the cool refrigerant or the very hot refrigerant, depending on what mode you're in, transfers to the coils inside that air handler. And then this is connected to ducts, and you can run large ducts. You can sometimes use existing ducts if they're hard or hard-sided, but I notice our bullet note says you can utilize existing ducts. Residential construction, if you have existing soft-sided flex ducts, you may not be able to reuse those, but there's some options if you're doing commercial project and you have hard-sided ducts. So these are good to know about because they can replace that FAU air handler and swap it out with heat pump technology. And then there's something called concealed ductless ducted fan coil, so also called pancake units. And these are relatively thin, meant to fit in attics. On one end is connected the return. On the other end is where the supply ducting work comes off. And we see these being used a lot in residential construction, where it's possible to have short duct runs. And you can also use more than one of these if you have a larger home and you want to zone it. When it
So,
comes,
hey, Jennifer,
yeah.
sorry, a couple of questions have come
good.
in. So before we move off of the heat pumps for space conditioning, we had a question about if there are shallow units that sit low on the wall. So we kind of have those big ones that are up high on the wall, and wondering if it's almost like either like a, you know, a shallow radiator type of heater for, which is maybe that one on the left.
Yeah, well, the ones that are floor, they call them quote unquote floor mounted. It's wall mounted, but it's at the floor level. And it's, let's see, can you see my arrow?
Yep.
Okay,
Yeah.
that's this
Okay.
unit. So the floor would be right here at the bottom.
And that's a split. So there's a condensing unit outside on that one.
Yes, so
And
you'd
then
have
that's
this.
the distribution. Okay, cool, thanks. And then as we get into the heat pump water heaters, there are some questions about, which I think you'll touch on, about clearances and venting, et cetera.
Right. And the other thing, like on these systems, except for that package system where the heat pump, the fan coils all in one, like you think of like in hotel motel room, the other systems all have outdoor units, and like the ductless system type to the right, it would have that outdoor unit and it can connect to multiple indoor units, or you can, you know, depending on the size of the building or the house will determine how a large capacity or even how many of the outdoor units you need. And then each of those outdoor units, depending on that capacity, could have 1, 2, or 4 indoor units connected to them. And they don't all have to be the same type of indoor unit. So you could have a house where you have a couple of wall mounted in the bedrooms, but you decide to do the ceiling recessed in like your living room area where you don't maybe have an obvious spot for a wall mounted, for example.
And with that, another question coming in here, in terms of those ceiling mounts that are kind of recessed in, Would that fit into a vaulted ceiling, or maybe only if there was a scissor truss with a little extra space? How much space do they need to be able to do that recessed ones?
Yeah, the recessed one residential size. So the one in the lower corner that's a square, that's meant, they now make one that's a 22 and a half inch square. So that the recessed portion was designed to fit into the trusses or the framing of 24-inch on center ceiling.
Mhm.
And they're installed flat, so horizontal. You wouldn't want to do them on a slope ceiling. If you had slope ceilings, you're going to want to go with a different type, but one that it doesn't really. Oh, actually, I'm going to show you some pictures. I think it's in here coming up of like how some of these could look, and then we'll hit more on the installation.
Okay.
That's
Okay,
kind
great.
of the quick overview. Yeah.
Cool. Thank you.
Okay, so with the water heater, I kind of alluded that there's the two types. Usually when you think residential or even like the multifamily projects, we talk about getting an integrated heat pump where the equipment's on the top, tank below, or a split system where the compressor, the fan, the evaporator coils, the condenser, etc., that's on the outside, and then water connection is all you need for the indoor unit. And I'm going to show you a little bit of what that can look like. Some of the kind of things to keep in mind for heat pump water heaters has to do with realizing that these heat pump water heater tanks that are integrated, this whole system is larger than a standard tank because now the diameter is a little bit wider, but mostly now you've got that equipment on top of the tank. So it just makes the whole thing bigger. But the clearances on the back and the side, similar to regular tank, a couple of inches, and then earthquake strapping. It would, and some of the installation would look like this, where you would need temperature and pressure discharge piping, either to the outside or to a floor drain. That's going to be the same on all tank type of water heaters, no matter, electric or gas. So that hasn't changed. The only thing that is different is you'll have a condensate drain line. And that condensate drain line is really a result of the warm air holds moisture inside your house or in your garage, wherever you have the tanks at, or even outdoors, right? The air has moisture in it, just naturally does. And when that moisture air hits something very cold, the water condenses out of it. It's like no different than when you have a cold drink with ice in it in the summer day. It Sure, it's summer out, but as soon as that air hits the drink, it condenses and that water drips down your glass. Same thing. So the same kind of mechanism happens here. So you have to have a place for the condensate drain line to go. So the architects just need to realize that and either call out that you've got the proper floor drain, or make sure that you've called out that that gets drained into, say, the drainage system, same one that you're maybe using for your washer or your condensing dryer, and or just sending it outside and then making sure you follow code for that condensate to go into a special rock filled drain channel area. So fairly straightforward, but that's just one piece you need to think about. But upside, no flue, no gas piping, none of that has to be taken care of. One of the things you may have heard about these is they do require a certain amount of volume of air, and a garage is often enough volume of air for these units to work. And the reason for that is if you can imagine this heat pump in a very small closet, for example, that's sealed off, well, if it's extracting the heat out of the air and ejecting cold air, then pretty soon the whole closet would be so cold, you're just not getting the efficiency you need. So there's kind of a rule of thumb on these units, and you need about 750 to 1,000 cubic feet of area that these units can pull the warm air from to heat that tank of water. If you don't have that kind of space, it's possible to do a ducted kit. And there's rules of thumbs for the type of duct and the distances and diameter that you would use for these units, but you could pull air from outdoors into the heat pump water heater, and you could eject that cold air either back outdoors in your house, or in some cases, some climate zone, hang on, they're experimenting with sending that in the summertime into the attic to push the hot air out of the attic and use that sort of free cooling to help create a cool lid over their whole house and further reduce their cooling needs.
Hmm.
With the split system, these things can be really, really handy, especially when you're tight on space. These tanks, I noticed the bullet note says tank temperature could get 130 to 176 degrees. Right now, Sanco 2 just says, okay, they guarantee like 140 to 150, but they can get hotter than that depending on location and piping length. There's no noise from these indoor units because it's literally a tank of hot water with no moving parts. So that's a huge bonus if you're concerned about noise, or your clients are concerned about noise with the integrated type. The noise would now be associated with an outdoor condensing unit because that's where the fan is. The other great thing about these particular units is they use CO2 as the refrigerant. So they have an extremely low global warming potential. They have a global warming potential of 1 because it is CO2 that is the refrigerant. And they work very cold temperatures, including below 0 Fahrenheit.
Jennifer, there
Yeah.
was a question if the split system heat pump water heaters are any more efficient than the integrated. Is there an efficiency difference, or just kind of the application and the depending on the space requirements and
Yeah.
global warming?
There currently we have one split system, and it's this one. It's Sanco 2. You can it was brand Sandon. I'm just realizing this link might be slightly outdated, but I do show the website. You could go to it. It'll take you to the current one. They rebranded the name for the US market. So it's called SANCO2, Sanco 2 water heater. And right now, this is the one you can readily get in our area. And it's very efficient. And then there are other integrated type systems that are as efficient, and there's a handful of those, but there's more to choose from on the integrated tank type and more brands to choose from. So you'll just have to kind of look and see what your price point is. This split system, it's more expensive. It's a couple $1,000 more expensive. So that's something for some people to consider. But if you're really tight on space, or you want something with low global warming potential, and if your clients are very sensitive to noise on the interiors, this could be a great a great solution. And then also, this system is used for something really cool that Andy's having done at her house that's going to become available in our area. Andy, I don't know if your house is kind of a test project, but it's combining the ability to heat the house and heat the hot water with this system all in one. And so in Andy's house, they're going to eliminate the gas furnace and not need it. They'll be able to just use the Sandco system here to heat the house and heat the hot water. So
Right. And the difference there is that in this system, for my house in San Luis Obispo, I don't need air conditioning. And so one heat pump will do the hot water, and that water will serve as the heat source for the heating the home, but it won't have air conditioning. And as far as I know, I think that's kind of pick two of the three. You can do, usually we do the heat pump that does heating the home and air conditioning, so all space conditioning, and then a separate unit for the hot water. That's the more typical one, but I don't know of a system. I think it's coming online, a system that can do all three with one heat pump, but I don't think it's at market yet.
yeah, okay. And then
Okay, we should keep going.
Yeah.
Sorry, go ahead.
Yeah, I'm going to just show you some pictures of, give you ideas of kind of what you could do, what this looks like. You're going to get a copy of the slides, so it's more about giving you kind of a visual on this. Just give you some idea on the clearances. You can group these together. They could be wall mounted, ground mounted. Do need to keep all the outdoor condensing units away from your dryer vents. You could fit them into really tight spaces, like in closets, under stairs. There are some, limitations on maximum vertical and maximum horizontal distance from the outdoor unit to the indoor water tank. But once you're at the indoor water tank, then that distance to all your plumbing fixtures is kind of standard, what you would use for any other type of tank, a tank of hot water. And just kind of heads up that to get the most efficiency, to get their highest efficiency out of this, you want all the pipes well insulated. And there is some new requirements in the 2022 Energy Code, sort of specifying your insulation based on the pipe diameter. So that's kind of a heads up. And then for another great way to really save on the hot water, and especially when you're also using like an on-demand recirc, a lot of these systems, these heat pumps, they don't want to have their water recirculated. They operate better when they have stratification in the tank, and it's just the way the whole system was designed, meaning you want all the hot water to naturally collect up at the top of the tank. So don't include recirculation pumps, and you need to follow the building code and make sure that if you do have some type of recirculation on the integrated tank type, that it's truly an on demand and doesn't send lots of cold water into the tank and ruin the stratification. And then this diagram on the right just shows something that's very handy, where you can use this to let that water flow through the pipe and bypass the shower head. And then as soon as it reaches temperature, you can pull that mechanism and get your hot water. So it's another way to save water and heat.
And Jennifer, sorry, Jennifer, you said, I just want to clarify for folks, you said you don't want to introduce a lot of cold water to your tank. You meant not a lot of warm water. If you're doing a recirc, then you're introducing warm water.
Yes. Good.
Yes, we knew what you meant. I'm just making sure that everybody listening,
yes.
we don't introduce a whole bunch of warm water. Okay.
Right. The tank, the whole thing works better on very cold water, meaning cold incoming water from the ground or city
Yeah,
supply.
the supply, yeah.
Yes,
Okay,
cold, yes.
keep
And then the
going.
recirc is like this warm water and it
Yes.
doesn't like it. Okay, just kind of a heads up, and we do other classes specifically addressing this, that you do need to be solar ready. I mean, sorry, to be electric ready. If their client does choose to install gas. And then one of the biggest hurdles is kind of cooking with gas. So Andy's going to give a quick overview of this, and then we'll hit on some of the other features that just go into more energy efficient building.
So one of the things that we have that the state figured out is that the all electric construction is cost effective, but really it's cost effective when it's all electric, right? So that if you are introducing gas just for cooking, you're spending a bunch of money, you know, $10,000-$15,000 sometimes for a gas meter and to get the gas from the street in the new construction. So if you can avoid the gas altogether, it's going to be a lot more cost effective. But what's happening is that a lot of cities, local jurisdictions are banning gas focused on new construction, right? So existing construction, that's going to be a challenge. And I know folks have called concern that the government is coming for their gas cooktop, existing gas cooktops. Nobody's going after that, but the new construction is a real opportunity. So we're in this mixed fuel transition. And so if we can figure out ways that people are changing out the appliances, then you're going to be kind of on that path. But for new construction, there's really a lot of emphasis of moving away from gas at all, which brings us to the cooktops. And the thing to just talk about with clients is the induction cooktops, rather than electric cooktop. If their experience is those old coils with electric resistance, or even if it's under glass, those things are just not very efficient and don't have great control. So just talk to them about induction cooktops. When we're in person, we kind of ask like who in the room has induction cooktops, and there's usually a few. Jennifer has one now. There's a tiny little learning curve and making sure you have the right pots, but they're otherwise faster than either gas or electric in terms of heating water. They're electromagnetic, so they heat the pot, so it's safer. The cooktop is doesn't have open flame. And there's the air quality issue. And so if you have an existing cooktop that's gas, I would encourage you to be thinking about how effective is your ventilation, because we are finding that that gas cooktops are emitting toxins more than we realize. And so if we have a tighter home, you might not be getting the air changes. So do think about either getting a better gas appliance if that's what your you or your client wants, or a better ventilation hood, or even localized exhaust are the kinds of options that would help to get the air changes you need. And then within new construction, there's actually a recognition now in the code about the potential harmful indoor air quality effects of a gas cooktop. And so they figure if the house is larger, then there's more air to diffuse, but if it's smaller, then it becomes more concentrated and more impactful to your health. So you can see here that it talks about the capture efficiency, and the diagram to the right is showing like a 55% CE, means that 55% of it goes up into the hood, but 45% is still going out. And so they're saying if you're over an electric range, induction or otherwise, then you need lower efficiencies than over the natural gas range hood. So in a small home, you need to have a really effective hood or a lot of air changes on that one. There's a note here about the ban on new gas all throughout the state, including Santa Barbara. Unfortunately, a lot of us have, including San Luis Obispo, based our ordinance in the city on an ordinance in Berkeley that currently is experiencing a legal challenge. So it's a work in progress. That's that fuel transition. So anyway, if you're doing the retrofit, there's all those pieces of getting the cooktop itself, maybe adjusting the panel where you put things in the circuit, or perhaps needing a new panel or service in the first place. But usually we have so much more efficiency, like in lighting, that we end up with enough capacity in an existing electrical panel to support the electrification.
Yeah, shall I jump in here?
Yep, all
Okay.
you.
Okay, so this is actually from my house when we were switching the gas unit to electric induction. And I just wanted to point out that when you talk to your clients about this, if you're doing remodel retrofit, if they don't have the proper electrical infrastructure, it's just going to add about $1,000 to the cost of that appliance swapping. So because of that, that's where we go back to that those electric ready requirements and under the new 2022 code, because it's basically saying your new construction project now is somebody else's remodel in the future. So to get across those barriers, the new code has shown that it's very cost effective just to include the appropriate infrastructure for swapping out your range, your furnace, your hot water heater, your dryers. So that's where that comes into play. And then to kind of wrap this all together, yes, we're looking at moving to electric appliances, energy efficient electric appliances, electric ready. But really, how much energy does your building use? It has everything to do with kind of the old school stuff we used to talk about, which is really good windows. And even the windows have gotten better, including even for non-res and high-rise, much better curtain wall systems. Need to think about sun control and overhangs, because even though we've been focusing a lot on the heating and cooling equipment, even in San Luis Obispo, you have, the temperature outside might not be that high, but inside your window, you could jump from, having maybe only 80 degrees outside, but actually hit 96 degrees inside the window, and causing even homes in San Luis Obispo to need air conditioning. So good windows, overhang shades, and operable windows, ways to vent, so you don't need the air conditioning. The better wall assemblies include exterior continuous insulation. So that's been in the baseline for the energy code for a while. It continues to be in the new code. And a lot of folks now are getting the hang of how to layer up these wall assembly components to include a rain screen and include that continuous interior insulation, so that the buildings themselves can use smaller capacity heating and cooling systems. And then when we think of heat pumps, especially those ductless systems, we cannot forget that our buildings still require a certain amount of outside air, fresh air, IAQ. And there are some simple systems for introducing balanced fresh air. Lunos is one where it's an inline wall fan system. And then Panasonic, for example, makes a small unit that exhausts and supplies semi-tempered air by running that through a heat exchanger. And then there's more advanced systems, which include ducting throughout the home. Renson is a brand I'm really familiar with. Zender is a system that a lot of some of the builders we know are using in our area. They each require just 3-inch ducts, but it's a supply return and then a heat exchanger. And that brings fresh air throughout the building. And then you can easily install the ductless type of mini splits.
This is a great solution for the person who was wondering about a cathedral ceiling, that if you have a one unit, one or two in a big house that is doing heating and cooling, but then use this ducted ventilation to distribute that air, that those little 3-inch ducts can just run up a ceiling, no problem.
Yeah, and then the whole discussion, right, of how are we going to get the zero net carbon, zero net energy buildings? It completely includes the renewable energy and resiliency in batteries. And so I'm going to give you just some visuals here of what these projects look like, because we know that they could be large scale and small scale, utility scale. We have to, as architects, we need to plan for those PVs and where they're going to be located on our residential systems. They're required. There's optional on the residential is for battery systems. So there's some things to know about that, but you could get some self-utilization credit in your Title 24s. And this slide is could be a handy reference for you. We included this. Just gives you kind of an idea of how much space you may need for your projects that want to include a battery system with the PVs and perhaps a car charger. And part of that electric ready now for the residential code for new construction single family includes battery ready. So there's some requirements that are going to come into play on the electric panel side of it. The occupancy types: high-rise, grocery, retail, restaurant, school, warehouse, auditorium, convention center, et cetera, et cetera. It's not all of them, but it's almost all of them are now requiring a PV system. And if the PV system is required, the battery is also required. And there's a couple formulas in the code that will help you, work with your energy consultant to figure out the size of PV system you'll need for these occupancies and the battery size needed. So it's part of that grid resiliency. But when it comes to batteries, there's just something I want to mention. It has to do with chemistry. The chemistry of the batteries, also the chemistry of the refrigerant that is used in the heat pump systems. So I encourage all of you to look for products that are using CO2 or other natural refrigerants, they're called, other low global warming potential refrigerants. And here's some images of a couple of brands that are doing that. Daikin now is offering a low global warming potential refrigerant for some of their mini splits. Sanco 2 has the CO2 refrigerant, same with the other commercial scale heat pump water heaters shown. And then when it comes to batteries, recently to market, they just got the UL listing in October of 2022. There's a new brand of battery called Salient Energy. They have a zinc ion. It's used water and salt. It's not flammable. It's not dependent on lithium. There's no thermal runaway possible with these. So these might be really appropriate for those multifamily and other public areas where batteries are being required, but where the safety is going to be extremely important. And then kind of bring it all home. Andy, you want to mention something about operational carbon and maintenance, and then we're wrap it up.
Yeah, so absolutely. I think that we're seeing an increased interest in, as we talk about energy efficiency and then electrification, but is it getting installed the way that it's supposed to be in terms of the functionality, and is it being maintained that way? So just kind of a keep an eye out that there's going to be increased both, I think, interest for owners to make sure that things are performing well, but really building departments, commissioning is required for commercial projects that's over 10,000 square feet. That's been in the code for a long time, as well as a design review as part of commissioning for even smaller non-res projects. There's envelope performance verification required in a lot of ways, a lot of types of projects, and then acceptance testing. So those are all being, they've been in the code or just have been increasing lately. And so you're going to be seeing some requirements for those types of forms. And as you bump into questions, a lot of this is kind of doing both in terms of the interest in carbon, just because that's where we want to go, but there's also the code driver. So if you do have any questions about the energy code or the California Green Building Code, 3C REN offers a free code coach service. You just go online and send an email through the form on the website. There's a phone number you can call as well. So if you just go online, Inbounds Green Consulting is a proud partner in providing that service, working with a team of our team of certified energy analysts, etc. And so I encourage you to use that. Itzel's going to close us out here, and then we'll have time for questions and discussion. We know it's your lunch hour, so after that, if you need to run, that's fine, but we'll hang out for question and discussion.
Thank you so much, Andy and Jennifer. That was a great training. Before I start doing the closing kind of remarks, I just wanted to launch a poll. Please let us know how we did today. All feedback is super helpful for us and very informative as we update or get new trainings into our calendar. If you have any questions regarding our AI available units, feel free to email me. I'll drop my email in the chat. I'm happy to assist if you have any questions on that. You should see the slides, a recording, and an additional survey coming into your inbox very soon. So watch out for that. And then just a reminder of the next classes that we have, part of the series. And I'll also make sure to drop the link to the rest of our calendar. We have a lot of great trainings happening this month and the next. So would love to see you, everybody in there. And with that, I'll hand it back to Andy and Jennifer to close out with any questions that anyone might have. Thank you.
Great. Thanks, Itzel. And they do have a ton of on-demand, all these courses that we've been teaching over, we and a whole bunch of other providers have been teaching for last couple of years are on demand. So if you want to take a deep dive into any of the topics, whether it's building code or building performance, check out their library. It's super helpful and informative. And if you want the next in this series, you do need to register for each one. So make sure that you go online to do that. All right. So Jennifer, we could probably stop sharing and just see if anybody has any questions. You know, we're fewer than 30 on the class here, so we can certainly have people unmute if they have a specific question that they want to ask. And for those who have to jump off, thanks again for being here. Questions or comments, anyone? I think we covered a lot as we went, so that was good to be able to. I think the heat pumps being able to address multiple uses. I think having to have one for hot water and another one for space conditioning is kind of a burden. I look forward to that, having a bit of a technology. Somebody's going to get clever and get that figured out for us. Anything else you wanted to touch on, Jennifer? We good?
Yeah, no, I just,
No?
if there's anything in the chat, I think that's it. I think we covered it.
We did it. All right. Good. People are getting on with it. All right.
Okay.
Well, thanks everyone. Have a great rest of your day.
Thank you. Bye.